Hey guys, welcome back to Data Products with R. In this lecture, we're going to be working on line plots. And so this is a bit of a hefty lecture because there's a lot of different options with line plots, and I didn't really know how to break it into multiple lectures. So with that, we're just going to get right into it and get going. Okay, first things first, open up your R and open up a markdown file. We'll call this one line plots. Let's get rid of all this jazz. Okay, so now let's change it up and look at some line plots. We'll start by making a custom data frame, kind of like the tooth data set. This way, you can see the lines and stuff that we're modifying. Oops. Okay, first things first, let's create a data frame called df and make it a data.frame. Dose equals our collection of d0.5, excuse me, d1, d2. And then we are going to say the length equals, so the actual values, 4.2, 10, and 9.5. Okay, so now if we run this, we should have a data frame up here. We click on it, and we have everything where it's supposed to be. Perfect. Okay, now let's create a second data frame for plotting by groups. Okay, so we're going to do data frame 2, and that is a data frame where our sup equals rep of VC, and you guessed it, OJ. And then each of them we want to rep 3 times. And then we want our dose to be a rep of D0.5, D1, D2. We're going to rep that twice. So as you can see, you don't need to put the each. You can put it in there so you know what it means at a later date, but you can also just put the number there. And so our length is going to be 6.8, so these are our actual values. 15, 33, 4.2, 10, and 10 and 29.5. And then we'll call it df2 just so we can look at it. There's only one key in rep. Okay, so here we go. We got our 3 vitamin C's or 3 orange juice, 0.5, 1 and 2 is rep for both, and then we have our lengths that are unique to each individual one. Okay, now let's again load ggplot2 and set a theme. Again, you can use whatever theme you want. I'm going to do ggplot2. And then we're going to do themes set. At this point, you probably have this all memorized. I'm going to do gray. And then I'm going to do legends position equals white. So why not switch it up? And then you got to have that closing parentheses there. Let's make sure we run this. Okay. All right. Now let's do some basic line plots. First, we will build a function to display all the different line types. Okay, so there are a bunch of different line types you can modify in ggplot. So we're going to make a function, and this is kind of for your portfolio or for your record, just so you can have them memorized and know what to play, how to play with it, right? Okay, generate our line types is going to be the name of our function. And then we're going to do this open bracket, and our function is going to be old par. You don't have to like memorize this. This is just for your record. Because this is a long lecture, I'm not going to spend too much time explaining. So par font equals 2, mar equals c, 0, 0, 0, 0. And then we're going to say plot 1 pch equals open and close parentheses y lim equals c 0, 6 x lim, so these are the limits of our plotting area, equals c 0, 0.7, access equals false, x lab equals nothing, so open and close brackets, y lab, which these are the labels obviously, nothing, and then for I in 0 through 6 lines C 0.3, 0.7, comma C I, comma I, comma L T Y equals I, LWD equals 3, text rep 0.1, bear with me, 6, 0 through 6, comma labels equals C, 0 point blank 1 point solid, two dashed. So we're putting the labels on our graph of what the line types are called. 3 dotted. Break it down the line here. 4 dot dash. 5 long dash, ling dash, long dash. And lastly, we're just going to do 6 of them. 6 Q dash. And then par mar equals old par mar, font equals old par font, close our curly bracket, and then generate our line types. Alright, let's see if this works. There's got to be a typo in here, right? This is a lot of typing. Yes, there is. Okay. Par, let me check my previously written code. Par font equals 2, mar equals C, 0, 0, 0. Oh, there's an M. Where's that M? Okay, comma. Unexpected comma. YLAM equals access equals false, xlim equals C. Plot 1 ch YLM equals C 0,6, xlim equals 0,0.7, access equals false. it's probably right here. Yep, okay. Let's get rid of that comma there after the 4. There we go. Okay. Oh, I forgot to call it as a function. Let's try this one more time. There we go. Look at that. All that to make this. Okay, so now you have an understanding of what numbers are associated when we get to the actual plotting and we use the line number, what they represent. So, okay, let's keep on moving. All right, now let's build a basic line plot. I'm gonna label this code chunk. We haven't been labeling our code chunks, so I'm gonna say basic plots. And so when it runs, when we knit our stuff, it'll tell us what chunks are being knit at the time, which is pretty handy when it gets caught up, because usually it just gives you a line number, and this makes it a little easier to figure that out. All right, so we're making a ggplot object where our data is equal to data frame, and our aesthetic equals x equals the dose, y equals the length, group equals 1, and then we're going to say our ggplot object plus, we're going to add geom line is the type of graph we're going to do, and then we're going to say plus geom point. And so if we run that, you see that we get points, and then we get lines connecting them. That's what the geom line does, and that's what the geom point does. It plots those according to our ggplot object. Beautiful. So, let me get rid of that. Okay, so now let's modify. Now let's modify the line type and color. So we're going to say R, and we'll call this chunk line type. You can call it whatever you want, but it's a good habit. I've really been neglecting to label my chunks and my stuff, and I need to be better at that. So it's a good habit to get into. All right, geom line type equals, we'll use, so you can use the words up here, right? So we're going to use dashed as our line type. And our color is going to be, we'll do something different, steel blue. And then let's add our geom point. And color equals, you can choose whatever color you want. I'm going to make it match, but you could do light blue, you could do whatever. All right. So now you see we've changed our points to blue, and we've changed our line color to blue and our line type to that dash that we had shown up here. Cool. All right, so we're getting some good customization here. Now let's try a step graph, which indicates a threshold type progression. So this is something where, you know, you get to a certain point and it jumps up in our data, right? And so instead of being like a normal distribution or a normal correlation, it's, you know, once you get to a certain point, what would be a good example of this? Nothing comes to mind. So you'll see, let's graph it first and then we'll try to explain it. Okay, so P plus, this is going to be easy, geom step plus geom point. Okay, so an example, so here we have our dose and our length. So what this is saying is that, okay, between the values of 0.5 and 1 dose, it's constant, right? But as soon as it gets to that threshold of the dose of 1, then our response or our length jumps to 10. And from dose 1 all the way to dose 2, so like dose 1, 1.1, 1.2, 1.3, etc., all the way up to dose 2, the length never changes. But as soon as you get to dose 2, then all of a sudden the length changes to 30. One example of this in my research is we did some work with Arabidopsis on the International Space Station. We were looking at how plants responded to blue and red light, right, and how they it's called tropism, how they would grow towards and away from light. And one of the responses to blue light, it appeared that as soon as you got to a certain gravity and light combination, then you'd always have this really robust response. So no matter how much higher you went, or the response wouldn't be more, and everything below it was kind of flat. So there's kind of a threshold type response. So there are examples in biology. It's hard to describe without showing the data. But yeah, anyways, we're spending a lot of time on this, so let's move on. Okay, now let's move on to making multiple groups. First, we'll create our ggplot object. Okay, so, and see, I'm already skipping my, we'll call this multiple groups, the name of our code chunk. So our plot is going to be ggplot df2, and our aesthetic is going to be x equals dose, y equals length, tooth length, and group equals sup, which was our supplement. Okay, so we've got our ggplot object now. Now let's change line types and point shapes by our group. So we're going to call this change line types by group. Okay. So take our ggplot object and add genome line, and our aesthetic's going to be line type equals sup, color equals sup, and geom point aesthetic shape equals sup. So we're just changing both color. So what we're saying is, okay, for our line type is going to be by supplement, VC or OJ, and the color we're going to differentiate based on VC versus OJ. And our points, we're doing the same thing, same code. And then we're going to say scale color manual, and we're going to say values equals whatever colors you want. I'm going to just be super basic, red and blue. All right. There we go. So now we've added multiple, so you can see that our symbols are different based on OJ versus the vitamin C, and our lines are different colors, and they're different, they're not really shapes, they're different line types, right? So three things to differentiate our two different groups. Okay. Now let's look at line plots with a numeric x-axis. So one thing you'll have noticed from this is that the distance between 0.5 and 1, which is a distance of 0.5, right? 0.5 plus 0.5 equals 1, is equally distant on here than the distance between 1 and 2, which this distance should be double, right? So we can account for that and we can change that. So let's do df3. It's going to be our third data frame, and it's a data frame sup equals rep c equals rep c, and we're going to do vc again, and we're going to do oj each equals 3, dose equals rep, C 0.5, 1, and 2. So you'll notice that before we put D 0.5, D1, and D2, and you can't treat those as numeric because they have numbers in them. So if we get rid of that, we can always write dose at the bottom, like it is already on this last graph, and just put 0.5, 1, and 2, and that'll treat it as those as numbers, and it will space them accordingly. Okay, so let's add our different values here for for our lengths. Okay, so now if we run this, it's the same as our last data frame that we had way up here, except you notice we removed the D's, so it's going to treat those as numeric now, and it will actually space our graph based on that. So it depends if you how you want to display your data. If those groupings don't have you don't want to show the numeric value, then having the doses, like they might have a number in them, but they might not actually mean a number that is quantitative across your x-axis. But if they do, in this case we'll say that they do, then you will want to treat them as numeric and space them out accordingly. And you'll see that our lines will look different after this. Now let's plot where both x's are treated as continuous labels. Okay, so df3 dose, and we're going to make sure it's numeric, so as numeric, and then as vector, df3 dose. So we're saying make sure that's numeric. Then we're going to pp plot, ggplot, data equals df3. Again, this is something you don't have to put data in there. You could just put df3. It just assumes the first thing's data. So that's why, I mean, it's for your recollection later if you come back and look at your code. All right, our aesthetic is x equals dose, the y equals length, group equals supplement, and our color we're going to equal supplement 2. And then we're going to do a geom line and a geom point again. All right. As numeric. Okay, so now look at these two graphs. You can see that this is the same data, right? But we're treating this as numeric now, as opposed to before we were treating this as just kind of categorical data. And so you see that now the space between dose 1 and 2 is much bigger. And so we almost get a direct correlation between the dose and the rate of tooth growth, which would make sense, right? The more vitamin C that you have, the faster your tooth growth. If we look at this previous graph where we treated numeric data as categorical data, then you see that we don't have a direct correlation, because this line we would assume that you would have like 22 tooth growth, and so it's very misleading. So it's important to treat numerical data as numerical and categorical data as categorical, right? So this makes more sense, and so that's one thing to keep in mind when you're displaying data. And that's why data products is super important. Data visualization is super important, because you can tell different stories based on how you present your data. If you wanted to say that there is a direct correlation between vitamin C and tooth growth, you would want to display it this way because this shows a direct correlation. If you were saying that there's no relation and that, or it's not, the more vitamin C you have is exponential almost, right? Your tooth growth. This graph would hint at that, even though someone with a keen eye would be like, well, this isn't spaced very well. Anyways, all right, off my soapbox. Let's keep going. All right. Now I lost where I'm at. Let's see. Now let's grab And all right. Okay, so I did the comparison, but we're going to do the comparison again, but that doesn't make sense because we have it up above. All right, now let's look at a line graph with having the x-axis as dates. We'll use the built-in economics time series for this example. Not very biology, but since we're just learning, we're going to just use this. All right, so if we look at the head of the economics data, you can see we have dates, and it's countries, population, unemployment rates, etc. So stuff we can plot. Continuous data with dates. Okay, so let's do ggplot data equals economics date, oh no, whoops, aesthetic x equals date, y equals, well, population growth over time, geom line is what we'll use. So we're just looking at the date and the population. So we have 1970 all the way up to 2000, this must be 2015, and you can see the population growth of this country. I don't even know what country it is necessarily. We could, we can find out. Let's do, look. U.S. Economic Time Series data. There you go. Okay, so it's the U.S. over time. Okay, now let's subset data. Okay, so SS is going to be our subset where we subset economics, and we're going to say that we want the date that is greater than, we're going to have to use the as date function so it knows to look at as a date and not just some weird number. 2006 1/1. So January 1st, 2006. And now ggplot data equals subset, aesthetic x equals date, y equals pop. So it's going to be the same function that we just did, but with our subset data. Oops. Okay. Oh. Economics not found. Economics. Well, we put 9 in there. Okay, so now we've just subsetted data. So, so you're probably like, why do we even do that? Well, I want to show you because dates are very important in data analysis for health science, for research, for any sort of stuff. Dates are important, right? Whether you're looking at time series data and things of that nature. And so R has a special ability to use things like the asDate function where you're able to tell R, okay, this isn't just some weird number, because if R would look at this and be like, okay, this is kind of numeric, but it's got dashes in it and stuff, so it would really be confused. Because if you were using it as a numeric and you said, pick the stuff greater, well, it's gonna be like, I don't understand what to do with these dashes in here. So it has annotation for dates, and so that's what's going on here, is that we're using the date function. I wanted to show you that because, like I said, a lot of biological data has dates. So going forward, okay. Now we can also change the line size, for instance, by another variable like unemployment. So we can make this 3D data, right? We have our population, and then we have the date, so how the population is growing, but then we can make the line size get bigger and smaller based on a third data or a piece of data like unemployment rate. So let's do that. ggplot data equals economics, aesthetic, x equals date, y equals pop, geom line aesthetic size equals unemployed divided by pop. So the unemployment rate per population, right? Because unemployment would automatically get bigger the larger the population is, but we want unemployment rate, so unemployment per 1,000 people. Okay, so here we go. So you see that, okay, we have the same line that we had before, but now how fat the line is dictates how much unemployment there is, right? And so you can see there's quite a bit of unemployment in the early 90s, and I'm surprised there's not that much around 2008 because of the financial crisis. And they probably, if we would have went like all the way back to like the Great Depression, I'm sure there would be quite a bit. Okay, so moving forward. Okay, we can also plot multiple time series data. ggplot, economics, aesthetic, x equals date, and I'm going to add a geom line, aesthetic, y equals piece of vert, color equals dark red, and geom line aesthetic y equals unempmed, color equals steel blue, line type equals 2-. What am I saying? Oh, UEM. There's no N. Okay, and so I am going to try to recall what these are. Actually, bear with me if this even comes up. Oh, here we go. Okay. So the UEMPMED is the median duration of unemployment in weeks. So like how long people were unemployed during that year, if they were unemployed, how many weeks. And the P-save rate, personal savings rate. So that's how much money that they had saved over that period of time. Like I said, it's all economic data. So just for your information, that's what they mean. Okay. Lastly, and then we'll be done. What are we at? Oh, half hour. Lastly, let's make this into an area plot. Okay. So let's quick get through this. So the reason we use this data is because we can make it into a nice area plot. So we're going to do ggplot, economics, aesthetic, x equals the date, and geom area is the type of plot, aesthetic, y equals our personal save rate, and that makes piece of vert. You can tell I hadn't looked at what the data meant in quite some time. oops, we're going to use all 9s. 1, 2, 3, 4, 5, 6 9s. And then we're going to say color equals, and we're just going to do the same thing, just to make it, you can do whatever you want, but I'm just going to do this. Alpha, so this is how transparent it's going to be, because we're going to look at them on top of each other. And then we're going to do geom, area, aesthetic, y equals UEMP med. So that was the median unemployment time. And we'll say fill equals, and I pick some weird E69F00. And then color is going to be the same thing. Oh, I have to put a hashtag in front of this, not a 3. I'm just going to copy this, so I don't have to type it out. You can put whatever color you'd like. I'm going to say alpha equals 0.5. And let's run it. Boom. So now you can see we have, it makes more sense, right? Because we want the reader of the graph to look at everything below this and be like, okay, there was this many people. It's really hard to see on my, you can see it a little better over there. This many people between 0 all the way up to 5% of people that had this personal savings or whatever. And you can overlay them and you can see, you know, where the line goes below. So it kind of trains the reader's eye to go after what you want to display. So, oops, how about I go to the right camera here? Man, this has just been a comedy of errors throughout this one. So yeah, so let's end it there. This was a bit of a longer one. I tried to aim for, you know, the 20 minutes and we almost doubled that. But we're done with line graphs. So I hope you enjoyed this video. If you're watching on YouTube, please hit subscribe. More to come. We'll be doing, we're getting through the basics here with all these different plotting things. We're going to get into interactive graphs and things like that with our Shiny package in the future. So I hope you enjoyed the lecture, and I'll catch you in the next one.